So we're going to talk about risk assessment, some of the advances and challenges, and I encourage you to ask questions as we go. Really do so. So let's get into this. We've all been, first question, how many of you, and I'll do a lot of this, ask you to raise your hand a little bit, how many of you have actually performed a documented risk assessment in the past? Okay. Well, hello choir, I'm the preacher. Great, that helps. That helps because that means we can move a little faster. So I presume you're familiar with the safety machinery, the 12,100, ISO 12,100 standard. That's been around since, well, it was published in 2010. Is that right? No, yes. Yes, 2010. It's the integration of three different standards, the 12,100-1-2 and ISO 14121. That put this all back together. It was an editorial combination, so it's based a little bit on some older information. We've learned a lot in the 15, 20 years since this standard was first written as EN 292. We've also seen progress in the Canadian standard, the Z 432, on safeguarding of machinery. We advanced the ball a little bit there, and perhaps more recently is the ANSI standard, the B11-0, safety of machinery. All these three documents basically build on each other's shoulders, and we all face the same problems. It's one of the things I've learned in my standards work and international work. We're all facing the same problems. We're all trying to come up with good solutions for those problems. And we're all mostly working together to solve these things. And we move the ball down the road. Now, these three standards are safety of machinery. And one of the things I wanted to talk about today was the Z 590.3 standard. And it comes based on, as an example, this was an example that I was doing a risk assessment with a company, training them on how to do risk assessment. And we had a group of, well, smaller than this, it was about 35, 40 people. And we broke into teams and we were working on risk assessments. And one of the items was this work area that involved this work platform. And it was late in the game because the millwrights were on the other side of the wall preparing to construct this work platform. But we went ahead and wanted to do a risk assessment of this work platform anyway. This is in the food baking industry. And what happens is left to right, product comes from left to right and it goes under that hopper. And in that hopper, flour is dispensed on top of the product and it goes off and away. Great. So we started to do a task-based risk assessment. And, of course, this work platform was designed to meet all the standard requirements for a work platform. Engineers had done their homework. It met all the requirements for the toe kick, the step height, the surface of the platform, the rails, the mid rails. It met all the requirements. We started doing a risk assessment and we identified a couple tasks. One of the tasks was somebody had to scrape down that hopper. The other task was they had to load flour into it. Well, the people on the team, we had like 5 people on the team, weren't all that familiar with how this was going to get done. So they pulled somebody from another team across the room and said, hey, come over here. And they started asking them these questions, like, how are you going to do this work? And his face went ashen. Because, of course, he was about 6 feet tall, so scraping out the hopper wasn't that big a deal, but he knew that his colleagues weren't as tall as he was. And so, what do you think the solution is to scraping out the hopper? How are you going to do that task? You're not asleep yet. What would you do?
Climb up.
Climb up. Well, that's one. All right. Well, so if we don't want people to climb up, what else are we going to do?
Lower it.
Well, we can't lower it. We can maybe raise them, right? So we'll put a step in there. That's pretty simple, right? What's that do to our compliance with the railing? Now we've got to modify the railing, right? Because the millwrights are ready to build this. The loading the hopper is a more difficult one. There is no more budget in this project to allow for a pneumatic conveyance of the flour up to the hopper. And it consumes about 50 pounds of flour an hour. There's also no way to put a hoist in there. You just don't have the footprint now. And the reason the guy's face went ashen, he says, you know what I'm going to do? I'm going to throw a 50-pound bag of flour on my shoulder and walk it up the stairs so I don't have to keep running up and down the stairs all day. We have designed in a hazard because we didn't understand the tasks that needed to be done. And now you're talking retrofit. And the question at the moment was, what are we going to do about this, because the millwrights are on the other side of the wall waiting. Do you want us to build this or do you not? What are we going to do? And it was not a very comfortable moment that we went through. But here we've designed something in, and one of the issues of the Prevention Through Design standard, the Z 590.3, was how do you prevent these kind of things? And we talked about the safety of machinery standards. This standard is actually focused on the end user of the machinery. Not the supplier of the machinery, but the end user primarily. This standard is the brainchild of a fellow by the name of Fred Manuel. And how many of you are familiar with that name? I mean, if you're in ASSE, you probably read his material. Fred is about 87 years old, and he's retired at least twice, and he's an ultimate failure at that effort. He's still writing books, and this standard is actually an evolution of one of the essays that he wrote in one of his books on prevention through design. I first had the opportunity to meet Fred and work with him on the Institute for Safety Through Design, which was part of the National Safety Council back in the mid-1995, about 1995 timeframe. The scope of the standard is pretty broad. The standard provides guidance on including prevention through design concepts within the occupational safety and health management system. It applies to the design and redesign of work premises, tools, equipment, machinery, substances, and work processes. And it works over the life cycle: construction, manufacture, use, maintenance, and disposal or reuse. It's very, very broad. It applies to many, many different industries. It applies to end users and suppliers, which differs a little bit from the ISO standards. In ISO, we can only write requirements for suppliers of equipment and machinery, because the end user requirements are based, as I understand it, are based on national laws. So ANSI doesn't have that limitation. ANSI allows us to put in both end user and supplier requirements, and that is included in this standard. It also is written to apply to both large and small enterprises, very large to very small. So the breadth of this standard is rather large. The application explicitly applies to the pre-operational stage, operational, post-incident, and post-operational. So again, it's a life cycle kind of standard. In Clause 4, it actually is titled Roles and Responsibilities, but interestingly enough, it only mentions the top management roles and their responsibilities, because it's focused at driving this process. So it states things like top management shall provide leadership to institute and maintain a policy and effectiveness process of the processes. And it gets into a little bit of the what, the when, and the how that this is to be done. Now, this is not a greatly detailed standard. It kind of gives you more of a general overview of processes and objectives. It's not going to give you a great detail of how to go about doing this, but it certainly gives a lot of direction in terms of requirements of what's expected. One of the more interesting clauses is Clause 5 on the relationship with suppliers, and talking about risk assessment and hazard analyses in terms of procuring equipment and machinery, having discussions. It actually encourages lots of discussion to go on between the buyer of equipment and the user before that equipment or machinery or facility come into being. It talks about specifications for risk assessment in the procurement process. It encourages views and reviews and testing, the FATs, the factory authorization testing, the validation testing, both at the supplier's facility before the equipment comes in your facility, as well as in your facility. It actually starts to describe how this should work together. And what it really does is it prompts folks to get into the details and get their hands dirty. Now, I know a lot of folks are already doing this, and that's great. It's just sort of codifying what is generally considered good practice. But there's also an awful lot of companies that aren't doing these kinds of things. Other content in the standard, Clause 6 is the design safety reviews, encouraging companies to actually have safety as part of their design reviews. 7 is the hazard analysis and risk assessment process, and that is the key aspect of the standard. Surprise, surprise, that's why I'm talking about it. Clause 8 talks about different techniques, and of course we all know there's different ways to skin the cat, there's different ways to go about doing risk assessment, and Clause 8 talks about some different techniques. Again, it's not a lot of detail about the different methodologies, more of an overview of the different things that are available. Clause 9 talks about the hierarchy of controls, and one of the interesting innovations of this standard is the idea of risk avoidance as at the top of the hierarchy. And I'm going to assume that you all know what I mean when I'm talking about the hazard control hierarchy, safety of controls, the 3-step method. And Fred introduced the idea of hazard avoidance as being at the top of the hierarchy, meaning we're not going to eliminate a hazard by design. Before we even get to that point, we're going to avoid bringing that hazard into our workplace. And this is a workplace standard. So, is that a great contribution, great addition to our hierarchy? Maybe yes, maybe no. It's certainly an interesting way to look at this. As every standard should have, it has a flow chart of the risk assessment process. It follows very similar to what we've seen in Guide 51 and in 12,100. There are differences. You know, we don't always agree on how that flow chart should look. In the CSA, the Z 432, we all have slight differences, but we're all heading in the northerly direction. Some are going northeast, some are going northwest, but we're all heading in the same direction generally. There's a fair amount of guidance information in annexes. There's a couple annexes, one of which talks about the rationale for the hazard control hierarchy. So we're going to talk about challenges, but I want to give you an update on ISO Guide 51. Now, Guide 51, how many are familiar with Guide 51? What it is? Just a few. Okay, Guide 51 is actually a document that is written for standards writers. And it kind of sets the ground rules for what standards should contain and how they go about including safety. It applies not only to machinery, but also consumer products. What is it, about 650 different standards will be based on Guide 51. So this is this covers a lot of territory. We are nearing the completion of the revision of Guide 51, and once that revision is completed, it will roll out to all these 650 different standards. So as those 650 standards are revised, they need to look to Guide 51 for the latest and greatest process on what's going on. One of the advances, you know, kind of a silly one, but how many of you heard of the word protective measure? Okay, very common term. We all know that a guard is a protective measure, yes? What about safety glasses? How many say yes, that's a protective measure? Okay. What about an instruction manual? Is that a protective measure? How about training? Okay. You guys are cheaters because you're well advanced in this topic. The new term that's going to be used in Guide 51 is risk reduction measure. And the reason is people seem to have some difficulty with protective measure and what does it all include, as opposed to risk reduction measure is a term that is pretty clear. If the measure helps to reduce risk, it's a risk reduction measure. You know, the idea that a warning label or training or instructions, is that a protective measure? Well, it's certainly a risk reduction measure. So we moved to that direction. We've changed the flow chart a little bit to try to highlight and clarify some things. Tried to simplify the language. I haven't heard anybody that's requesting that standards include more complex language, so we've tried to work to that. So let's talk about the challenges and where the wheels come off with this risk assessment stuff. And of course, I've written a book. All speakers have to talk about their latest book. You can find more information about it. But in this book, I talk about the challenges and opportunities. And one of the things about risk assessment that I've run into is that people have a lot of difficulty with getting their head around why we have to do this. And back in 1995 time frame, when I first started getting involved in risk assessment, the kinds of questions that I got when I started talking about risk assessment was, what is it and why would I care? And the third question was, well, how do I avoid having to do this? And you saw a lot of that, particularly with engineers. They sort of look down the path and they see what this is involving, and they figure out, all right, I'm going to be doing something else and let somebody else deal with this. And in fact, I was talking with one company where the safety guy brought us in and wanted to really get and deploy the risk assessment process, and he thought it was a great idea. He had a room full of about 9 engineers. And the safety guy was saying, this is the path we need to go. It's going to be great. And what needs to happen at the end, towards the end of the meeting, it became clear his idea, his vision was that the engineers would be doing risk assessment, and he would be sort of the central focus to manage the information and the files and such. But the actual real work was going to be done by the engineers. And one of the engineers piped up and said, you know, that could lead to a lot of variation and inconsistencies in our risk assessments. And what really should happen is you should be the lead guy for the risk assessments. And we'll help you, but you should be the guy taking... That went nowhere. I was thanked for my time, nice to see you, and I never heard from them again. The safety guy didn't want to be the lead on doing this. Now that's changed a little bit. I mean, certainly now the kinds of questions that I receive talking about risk assessments is, well, at a much more detailed level. You know, how do you integrate this into your business processes? The familiarity that they have with assessing severity or probability or where the difficulties are, and how do you incorporate this, or which standards should I use when I've got competing standards? If I've got a robot standard and I'm working in the semiconductor industry and both have standards, which ones should I use? How do I work that? Those are the kinds of questions that we're getting now. And in fact, converse to the story I just told you, I'm seeing people that are moving into risk assessment as a career opportunity. Talking with major companies that are rolling this out at a global level, realizing, hey, this is going to get some pretty good focus in the organization, a lot of good return. This is where I want to go. So it's kind of interesting to see how this has changed in the last 15 years. So one of the biggest challenges we have in working with risk assessment is the idea of acceptable risk. And acceptable risk is the key criteria for Z590.3. in terms of, that's when you're done. It's also the criteria in the B11.0 standard. So you're done with risk assessment when you've reached acceptable risk. You have identified all the hazards, the reasonably foreseeable hazards, and the tasks associated with the hazards, and you've reached acceptable risk. You're done. Check. Okay, so what's acceptable risk? Wow. I got to tell you, that was the most difficult chapter in writing in that book. It's probably the longest chapter. 2 simple words, acceptable risk. Man, you can go really deep in this topic, and because people really struggle with it. And sometimes you wonder, why is it so hard? Because we deal with this every day. You know, how many of you work for a supplier of machinery? You know, just a few, okay. How about an integrator system? Some integrators, good. How many people use machinery in their facilities? Few? Okay. So we make decisions about acceptable risk every time we ship a machine, every time we turn one on, right? We do this without a lot of thinking. We don't have a lot of hand-wringing that goes on about, have we achieved acceptable risk? But it's a hard topic. And one of the elements that's come out that I've identified in my work is what I call the precision trap, which is, you know, our goal is to achieve acceptable risk. And we work the process of identifying our scope of our assessment, we identify the hazards, we assess the risk, and then we want to get to reducing risk to get to acceptable risk, right? And we run into challenges with assessing risk. This is where the wheels come off all the time. And pretty soon, the discussion changes from how do we achieve acceptable risk to, well, how do we quantify the risk? And how do we get more precision? And as engineers, we've been trained to understand that how do you take a complex problem, a big, hairy problem that's subjective, and make more sense out of it is you break it into pieces and you bring some focus into it, you quantify what you can, you evaluate the uncertainty, and you get a better answer because it will allow you to make better decisions, right? Or do you? And I'm not certain of that. This is kind of a research question in my mind because many times I see the focus of the risk assessment now becoming the discussion about quantifying risk and which risk level are you in and the uncertainty associated with risk and the precision of the assessments. I mean, some of these assessments go out to, well, look at 13849-1. You know, how many significant digits are we talking about with the validation of the control systems? Really? We're talking about, it's a hard question, and I don't know the answer to it, but I do know that people get tripped up a lot in trying to achieve acceptable risk and getting focused on things that don't matter as much as we think they might. At least that's my opinion. And certainly there's others' opinions. I mean, I welcome other opinions on that. One of the reasons this is hard is the discussion about, is zero risk the only acceptable risk? All unsafe conditions must be eliminated, therefore zero risk. Well, you talk to most engineers and they don't have a difficult time with this. Some safety people do, particularly ones that have been ingrained in the States. It's the OSHA mentality, because OSHA says we will have no unsafe exposures. But zero risk is not attainable. And if we can agree that zero risk does not exist, then that means that there will be some exposures that are unsafe. And that will be part of our work. And we just have to accept that. And if you can get past that, that's great. If you can't, the wheels will not roll. Particularly if you have on your risk assessment team somebody that has this view, you're not going anywhere. Another difficulty is the philosophical differences, and these are not easily resolved at all because there's little middle ground between a zero risk view and an acceptable risk. What's our goal there? There's no middle ground. And some of the industry standards, like the robot standards, they set specific levels of what is acceptable risk. You have to hit to an R3 or an R4 before you're done. That is what is considered acceptable in the robot industry. And you can do that with a fairly narrow focus like robot applications. Other standards explicitly don't give the answer to what is acceptable. They give the process to allow you to follow the process to an outcome, and you make the decision about what is acceptable. Well, there's no common ground between folks that want to set a specific level of what is acceptable and those that don't, because those that don't explicitly don't want to. They want to leave the decision to the user of the document. Not much common ground there. Acceptable risk is a subjective question, and it lacks, in most of the applications of risk assessment that I've worked with, we lack quantitative data. It would be great if we had it, but we just don't have it. So it becomes a subjective decision. And even if you have some numerical data, the decision to accept risk still is a judgment call. And as Fred Manuel wrote in one of his books, in reality, the risk assessment process is as much art as it is science. And when you start putting numbers on this and you manipulate them, you multiply them or add them to get risk levels, and they come out to lots of significant digits, they start to appear like it's science, when it really isn't. Time pressures are another reason why this is difficult. I mean, few of us have the luxury of time to spend talking about what is acceptable. And if you've ever been in a team or in a standards committee where you're talking about what is acceptable, you know it can be very, very hard. It's a hard conversation because you have such different views, and it can soak up a lot of time and energy. In the States, product liability adds a lot of complications, because if you set a specific level that says this is what is acceptable for risk, and my machine can't meet that, and it's very reasonable that I can't meet that, I've got some real product liability concerns. Which leads us to the circle of frustration. So what is acceptable? Acceptable risk is that which is practicable. Okay, great. What's practical? Well, that which is feasible. What's feasible? Well, it depends on what's acceptable. You go round and around this. So let's look at some rules for what is acceptable risk. Clearly, you would agree with me that no employee shall be exposed to a risk of catastrophic injury. Anybody disagree with that? How many of you worked in the steel industry? When you make steel, that's hot glowing steel. It's over 1,000 degrees Fahrenheit. Before I took the picture, that chain was down. The steel workers do have to walk across that. Yeah, that's part of the job. Now, they don't spend a lot of time there, but they have to walk across that. And in the aluminum, when you make aluminum, it's even more difficult because it doesn't glow. Hot aluminum and cold aluminum look the same. All right, well, let's look at another one. How about no employee shall work on live electrical power? Anybody been a lineman? Right? The safest way to do this would be to lock out the power. But we like to have conferences and like to have the lights on while we're talking. So those guys have to go out there in the real world and work on live high voltage lines. And they have lots of training, lots of specialized tools, personal protective equipment. They use bucket trucks when they can, but sometimes they have to climb the poles and go out there and do this work. How about this one? All high risks are unacceptable and must be reduced. Everybody agree with that? High risk is just not acceptable, right? Welcome to Vancouver. This is photos taken in Vancouver. The speed limit on that road is about 80 to 100 kilometers per hour. So we've all done risk assessment before. What's the severity of injury of somebody? I mean, look how close those poles are to the edge of the road. What's the severity of injury in this one? Pretty high? What's the probability of the occurrence of harm? Okay, we got to say it's kind of up. I mean, we know as a society somebody's going to wrap their vehicle around that. Maybe not on a Tuesday morning going to work, but Saturday night, it goes up higher. That's a high-risk situation. And okay, this isn't a work site unless you've got folks out on the road. How many of you are familiar with gaming systems? You know, the Xbox, Wii, your kids, all right? Are you familiar with the epileptic hazard of that? People are susceptible. Yeah. People are susceptible to stimulation from the light on the games. There's no way to tell, the manufacturers can't tell who is susceptible and who is not. So what can they do to prevent this hazard, to reduce the risk from this hazard? They do the following. They give warnings. Play as far back from the screen as possible. Play on the smallest available television. Do not play when you're tired or need sleep. Play in a well-lit room. And take a break, 10 to 15 minute break every hour. Yeah. Your reaction is the exact same as the kids, although the kids, when you talk to a university, they're louder when this. They play as close to the television as possible with the biggest screen they can find. They play when they're tired or need sleep because this is a form of recreation and relaxation. They play in a dark room because it enhances the experience. And they take a 10 to 15 minute break every 24 hours whether they need it or not. So let's do a quick risk assessment on this. To the individual player, what's the severity of harm? To the individual player, if you are actually subjected to this hazard, that means you're going to suffer an epileptic seizure and now have epilepsy in some form potentially as a result. I would say that's a pretty significant or catastrophic event in my life. What's the probability of harm to that individual? It's pretty remote. It's very low. How about to the manufacturers of these systems? I'd argue it's high. It's very likely that we're going to hurt somebody. That's a residual risk that's high. If that is not acceptable, well, if it is acceptable, that means we know we're going to harm people with our product. With certainty, we're going to hurt people. If it isn't considered acceptable, we can't make that product. That means you can't build the systems, you lost all the hours of entertainment, all the jobs associated with building the hardware and the software, the sales and support, all that goes away. It's unacceptable. And let's talk about the lost revenue too. That's a high risk, and it's considered acceptable. There's not very many of these that occur that I've seen, but there are some. And so these rules on acceptable risk are difficult, particularly if you start drawing bright lines. And you know, saying a high risk is unacceptable seems like a pretty easy, bright line, but you can find exceptions to those. And I think that's one of the big areas of risk assessment that we need to focus in on, is how do you handle and work with this idea of what is acceptable? Because although it's a hard topic, it's also one that we work with every day without a lot of training and guidance on how to go about this. Now, you know, the different standards that we have available, such as 12,100 and the Z432 and the B11.0, all talk about safety of machinery, and that's one element of safety that addresses the suppliers, primarily the suppliers of machinery. The Z590.3 addresses the users of the machinery primarily, and that's cutting across a very wide swath of industry. And I'm pretty excited to see where this is going, because I do believe that with companies that I've talked with and I've understood, they have been very successful at reducing their incident rates of injuries. And they're hitting a plateau. And several have come to the conclusion that the way to get to the next level, I hate using that phrase, but I don't know a better phrase yet, to improve their process, to reduce their rates further, is through risk assessment. So I think this is going to go some really interesting places, and that's why I find it to be very exciting to be part of it. I'm going to stop there. Thanks very much for your time. Appreciate your attention. I'm glad you stayed awake. I'll be around, and if you have specific questions, let me know.
Thank you for